Hello, hello, my dear friends. Anyone is in live? Hello, my dear friends. Anyone is in live? If anyone is in the live, just say me hi. Hi, Dinesh. Any other? Still any other? Hi, Praneeth. Hi. No. Right. Now, in the last class, we have studied up to preparations of the amines, right? Now, the up to the preparations of the amines we have done. And today's lecture, we are going to see the basicity of amines and the aromatic electrophilic substitution reactions of the amines. Clear? Now we'll start the lecture. Wait a minute. We'll start our lecture. Hi Murli, hi. Hi my dear friends, hi. Now, right. Now in the last class, we have seen up to the how to prepare the amines. Now we have seen. Now in this lecture, we are going to see the chemical properties of the amines. In that chemical properties of the amines, in that the first we are going to see the hi to everyone. Now here, now we'll start our lecture. The first one we are going to see, that is a basic nature of amines. First one that we are going to see, the basic nature of amines. Right? Now in this basic nature of the amines, my dear friends, the many of the students, they are getting the difficulty in identification of the basic nature of amines. In the basic nature of the amines, first how to decide the basic nature of the amines. Now to decide the basic nature of basic nature of the amines, first nitrogen, this amine, let's suppose this is RNH2. This RNH2, this nitrogen lone pair of electrons should be given to the electron deficient species very fastly. Let's suppose this is a nitrogen, it is an electron deficient. Hi, Hithin. Good evening, good evening. Now, this nitrogen lone pair of electron, when if it is donated very fastly to the electron deficient species, then after when it has donated, now what we will get? It will become the conjugate acid. After donating the its lone pair of electrons to the electron deficient, it will become the conjugate acid. After becoming the conjugate acid, this conjugate acid on the nitrogen should be stabilized. If this bond pair of electron, if the bond pair of electron on the nitrogen, this nitrogen positive charge of the electron, if it is stabilized by the plus I groups, that amine or that compound is a more basic. Clear? Means plus I groups increases the stability of amines. Right? Next, minus I groups decreases the stability of amines. Clear? Now this is a one key point you have to remember. Now, if suppose they have given one aromatic, one aliphatic amines and one aromatic amines they have given, let us see. one aliphatic amines, one is a aromatic amine. Now this is a aromatic amine, aniline is a aromatic amine, we know. Now here among the aliphatic amine and among the aromatic amine, if they have given, now aliphatic amines are the more basic than the aromatic amines. Why? Because now in these aliphatic amines, this lone pair of electron will be participated in the resonance. Now, in this aromatic amine, this lone pair of electron, if it is participated in the resonance, now this lone pair of electron is not able to give to the electron deficient species. Right? Now, in this aliphatic amine, here there is no any resonance involved. It will very fastly, it will be given to the electron deficient species and it will become more stable. You have to be very careful that aliphatic amines are more stable than the aromatic amines. You have to be very careful, my dear friends. Aliphatic amines are more stable than the aromatic amines. Now, this is the one very important. Actually, if suppose one CH3NH2, one methylamine, first one, and the second one, if they have given the CH3NHCH3, right, and the third one CH3N, this is a 3-degree amine, clear, and fourth one in the NH3, if suppose they have given, and if they ask what is the basic nature of these amines in gaseous phase, two types of the basic nature of the amines we are having for the primary amine. In the gaseous phase it is different, and in the which one, in the liquid phase it is different. Now I was asking in the gaseous phase. Now can anyone say me what is the order of basic nature of these amines? What is the order of this basic nature of amines? What is the order of this one in basic nature of amines? What is the order? Can anyone say me? In the gaseous phase, now what is the order for this one? Now in the gaseous phase, the order, basic nature of this amines order will be 3 greater than, 2 greater than, 1 greater than 4, right? 3 greater than, 2 greater than, 1 greater than 4. But when it comes to the same thing, the same question, if they ask in the liquid phase, if they ask in the which one? Liquid phase. My dear friends, in this liquid phase, we are having the amine. This is the one amine, right? Amine. Now in this liquid phase, what the liquid phase will be there? In the liquid phase, we are having the H2O. We are having the H2O. Now in this H2O, yes, good, my dear Pranit. Now in the H2O, you are having the partial negative charge. Now these hydrogens are having the partial positive charge, right? Now this nitrogen lone pair of electron, this nitrogen, it is having the partial negative. It will form the bond with the hydrogen of the H2O in the liquid, and here we are having the hydrogens, right? These hydrogens are having the partial positive charge. Clear? Now these hydrogens will form the bond with the oxygen, partial negative charge. Now this type of the energy we call it as a salvation energy. Clear? This type of the, when this hydrogen, when it is forming the bond with the which one? Oxygen or H2O. Now the energy released we call it as a which one? Salvation energy. Clear? Here the one salvation energy and one inductive effect. It is having the some complicated explanation we are getting here. My dear friends, here we are getting some complicated explanation. No need of that complicated explanation for this one. Some salvation energy will be dominate. Sometimes inductive effect will be dominate. It is having some complicated explanation. So no need of going to complicated explanation like salvation energy and plus I, and you will get confused. Sir, why only the secondary? Why when it comes to the ethyl, the order will be changed. When it comes to the methyl, order will be changed. So no need of this complicated explanation. Just you remember, whenever this type of the methyl, which one? Methylamine, and when the R is methyl, then in the liquid phase, the order will be 2 greater than, 2 degree greater than, 1 degree amine greater than 3 degree amine greater than normal ammonia. Now this is in the liquid phase, but the same thing, the same in the liquid phase, irrespective of the which one, irrespective of the methyl, if they are given the ethyl NH3, ethyl NH2. Now the second one ET, here the NH and here it is a ET, right? Now the third one, now 3 degree ethylamine, 3 degree ethylamine, and fourth one ammonia if they are given. Now in the liquid phase, this order you say me in the liquid phase. In the liquid phase, you say me the order. What is the order for this one in the liquid phase? What is the order? Order for this one? What is the order for this one, my dear friends? No, it is not same. No, it is not same. No. For the methyl it is different. For the ethyl it is different. My dear friend, for the ethyl the order will be 2 degree amine greater than 3 degree amine greater than 1 degree amine greater than, last is a 4. No. For the ethyl and the methyl the order will be different. You have to be very careful. That's the reason I said you. Now if I explain that solvation energy and the inductive effect, something you will get the difference. So with the ethyl case, 2 degree, 3 degree, 1 degree and normal amine. For the methyl case, it is 2 degree, 1 degree and the 3 degree and it is amine. So you have to be very careful. If the ethyl, if they are given, you have to be very careful. Right? Only if the methyl only if they have given, the order will be 2 degree, 1 degree, 3 degree and amine. If suppose the ethyl if they have given 2 degree, 3 degree, 1 degree and the normal amine. Clear? Yes. Only in the methyl and the ethyl case. If the ethyl amines they have given 2 degree, 3 degree, 1 degree and the normal amine. If suppose the methyl they have given 2 degree, 1 degree, 3 degree and the normal amine. Okay. This is very important. You have to be very careful with this one. Whether they have given the ethyl or whether they have given the methyl or whether they have given the ethyl, you have to cross check. Ethyl they have given in the liquid phase, if they ask, then the basic nature order will be 2 degree greater than, 3 degree greater than, 1 degree and the normal amine in the ethyl case. In the methyl case, 2 degree amine greater than, 1 degree amine, 3 degree and the which one? Normal ammonia. Is it clear? Is it clear or still you are having any confusions? I hope it is clear for you. I hope it is clear for you. Is it clear or still you are having any confusion? Is it clear? My dear friends, is it clear or still you are having any confusion? Right. Now, next, the next topic we are going to see the test for the amines. Now, the test for the amines in the first one, we are going to see the carbylamine test. The first one we are going to see the carbylamine test. In this carbylamine test, will be given by the only 1 degree amines that we know. It will be given by the 1 degree amines. Clear? Now the 1 degree amines. Now what is the reagent of the carbylamine? Can anyone say me what is the reagent that we are going to use in the carbylamine? Can anyone say me what is the reagent that we will use in the carbylamine test? What is the reagent that we are going to use in the carbylamine test? Same. That is like the chloroform plus KOH and heating. Chloroform, KOH and heating, and the product we will get it as a what? Isocyanide we'll get. Product we will get it as a isocyanide, and this is having the foil smell. Clear? Now the 2-degree amines, if suppose the 2-degree amines if they are given, upon carbylamine reaction there is no reaction. Clear? Now this carbylamine will be used to give the test for the, it is used to test for the 1-degree amines and the 2-degree amines. Now let's suppose if suppose the isocyanide they have given, like this isocyanide they have given, isocyanide upon LAH they have given, and cyanide upon LAH they have given. Now what is the product you will get, my dear friends? Can anyone say me? What is the products you will get? Good evening, Captain America. Good evening, good evening. Can anyone see me? First one is a 2-degree amine. Yes. First one is a 2-degree amine, and the second one is a 1-degree amine. Right. Good. Now, clear? Now, next one, R C triple bond N and sodium plus ethyl alcohol if they are given. Now, what is the product you will get? What is the product you will get? And what is the, no, only one important concept you have missed, that is a basic nature of amines that you can see once the live end. My dear friend, what is the product you will get it here, and what is this reaction name? Now, what is the product you will get, and what is the product you will get it here, and what is this reaction name? Can anyone? Now, what is the product you will get, and what is the product you will get here? This reaction here also you will get the primary amine only, and this reaction we call it as a Mendes reaction. This is very important. Now you have to be very careful. Here, and this reaction we call it as a Mendes reaction, right? Now sodium in the presence of ethyl alcohol, this cyanide will be converted into the primary amine, and this reaction we call it as a Mendes reaction, right? Here, done. Ethyl added, no, 1-degree amine only. No, it will give you the 1-degree amine only. It will give you the 1-degree amine only. Okay, right? Now, next one. Right. Okay. This is Mendes reaction. Now, next one, reaction with. Yes, it is more enough to watch this lecture, my dear friend. Now, the next one, reaction with nitrous acid. Reaction with nitrous acid. Reaction with the nitrous acid. Now, here the reaction with the nitrous acid also, this is very important. This reaction is to test 1-degree, 2-degree and 3-degree amines. 1-degree and the 2-degree and the 3-degree amines. Now we know 1-degree amine upon nitrous acid it will give you the N2 gas. It will give you the N2 gas. 2 degree amine upon nitrous acid, it will give you the yellow oil liquid. Yellow oil liquid. Clear? Next, 3 degree amine upon nitrous acid, it will give no reaction. No reaction. So just the trick you have to remember that it is a NaGGYN. Upon nitrous acid reaction, 1 degree amine will give you the nitrogen gas. 2 degree amine will give you the yellow oily liquid, and 3 degree amine no reaction. 3 degree amine no reaction. Here remember like the noggin. Remember like a noggin. Okay. This trick is known as a noggin. Now we'll see how the amine, 1 degree amine will give you the nitrogen gas, and this nitrogen gas upon this RNH2 or 1 degree amine, when it is reacted with the NaNO2 plus HCl, NaNO2 plus HCl or nitrous acid, if it is reacted, now the first it will be converted into the it will be converted into the diazo. It will be converted into the diazonium. It will be converted into the diazonium, and the H2O will be generated. H2O will be generated. Now we know this nitrous acid upon nitrous acid upon amine, it will be directly converted into the which one? Diazonium, right? Now this diazonium, and it will generate the H2O. Now this N2 being the good leaving group, it will be eliminated. As the N2 when it has eliminated, now as the N2 gas when it has eliminated, we will get the carbocation like this. Now in this carbocation again we are having the H2O here. Whatever the H2O it has generated in the reaction, now in this H2O we are having the OH minus. OH minus will go and attack to this carbocation, and it will generate the alcohol. It will generate the alcohol. My dear friends, you have to be very careful that 1 degree amine upon the nitrous acid when it has reacted, now the final product is not the diazonium. The final product is alcohol. Final product is a alcohol. Clear? You have to be very careful in this one. The final product will be the alcohol. The final product will be the which one? Alcohol. Right? Right. This is about the 1 degree amine. This is about the 1 degree amine. Now if you take the 2 degree amine, now this is a 2 degree amine. This is a 2 degree amine. Now the 2 degree amine upon nitrous acid. Now this is a nitrous acid. Right? Now as the H2O it will be eliminated. Now as the H2O when it has eliminated, now we will get the one yellow color oily liquid. Now this is a one yellow oily liquid. This is a one yellow oil liquid. Now for the 3 degree amine, there is no any hydrogen to react. Now this is a 3 degree amine. No reaction. Right? Now this is about the reaction with the nitrous acid. But this one is very, very important. Now you have to be very careful. Many of the questions they are asking from this one. So amine upon the NaNO2 HCl, many of the students they will stop the reaction at the which one? Diazonium case, but the reaction, the final product is a alcohol. Because when the NaNO2 HCl when it has reacted, now in the solution the H2O is generating. This H2O will be attacked to this carbocation. Now that carbocation of this OH minus of the H2O leads to give the alcohol. Right? Now next one, the another type of the test we are having. Good evening, Bhautik, good evening. Next one we are having the Innsbruck. Next one we are having the Innsbruck test. Now in this Innsbruck test, this is Innsbruck test. This Innsbruck test is used to test for the 1 degree, 2 degree and the 3 degree amine. 1 degree and the 2 degree and the 3 degree amine. Now, what is the Innsberg reagent? Innsberg reagent. Innsberg reagent. Innsberg reagent is nothing but benzene sulfonyl chloride. Benzene sulfonyl chloride. No. Only just basic nature, basicity of amines. Then after that, after the basic nature of amines, carbylamine. After the carbylamine, reaction with nitrous acid. Now this is a third topic. That's it. Innsberg reagent. No, more the chapter it is there. Now this is a Innsberg reagent. This one we call it as a benzene sulfonyl chloride. Benzene sulfonyl chloride. Benzene sulfonyl chloride. Now in this benzene sulfonyl chloride, 1 degree amine upon Innsberg reagent soluble in alkali. It will be react and it will be soluble in the alkali. And 2 degree amine upon the Innsberg reagent insoluble in the alkali. Now 3 degree amine upon the Innsberg reagent, no reaction. Remember this Innsberg reagent trick like a asin. It is like the asin trick. You remember like this asin. Means Innsberg reagent. This is a Innsberg reagent. 1 degree amine soluble. 1 degree amine soluble. 2 degree amine insoluble. And 3 degree amine no reaction. 3 degree amine no reaction. Right? My dear friend, amines is nothing but nitrogen containing compounds only, right? Amines is nothing but amine is a one nitrogen only, right? Nitrogen is here, you can see. Here this is a 1 degree amine. Now this nitrogen is attached to the carbon, right? This nitrogen attached to the carbon is nothing but nitrogen containing compounds, and the amines are same. Don't get confused. Both are same only. Clear? Now this is the Innsberg reagent. Now Innsberg reagent, remember asin. Now how the 1 degree amine is reacting? Now we'll see. How the 1 degree amine is reacting with the Innsberg reagent? Now we'll see. Here the 1 degree amine. This is the 1 degree amine. This 1 degree amine, when it is reacted with the benzene sulfonyl chloride. This is a benzene sulfonyl chloride. Now this nitrogen lone pair of electron will be attacked to the sulfur, and the chlorine good leaving group it will be leave. Clear? Now the nitrogen will get the positive charge. Now the nitrogen, when it is get the positive charge, here the sulfur, here the double bond O, here the double bond O, and here it is a. Now here the double bond O, and here it is a double bond O, and here it is a pH. Now the nitrogen, it is getting the positive charge. To stabilize this hydrogen sigma bond pair of electron will be given. Now here the R, here the nitrogen lone pair, and here it is a H, and here is a double bond O, and here it is a double bond O, and here it is a pH. Now when it has reacted with the base, the base will readily abstract this acidic proton, and this acidic proton is stabilizing by the resonance. Clear? That's the reason this is soluble in the base. It is soluble in the base due to the presence of this acidic proton. Right? Next one. If suppose the 2 degree amines if they are given. 2 degree amines if they are given. 2 degree amines if they are given. Now this is a 2 degree amine. Now 2 degree amine upon benzene sulfonyl chloride. Now this lone pair of electron will be given to the sulfur, and the chlorine being the good leaving group, it will be eliminated. Then after that H, here the H, and here it is the here it is a H, Here it is a R and here it is a H. Now here it is a S double bond O, and here it is a pH. Now nitrogen, it is getting the, to stabilize this nitrogen, now its sigma bond pair of electron has been given. Now we'll get the R double bond R, and here the S double bond O. Now when we reacted with the NaOH, when we added the NaOH, for this NaOH there is no any acidic hydrogens in this compound. When there is no any acidic hydrogen, so it is insoluble in the base. It is insoluble in the base, and the remaining further reaction will not be happened. Now if you take the 3-degree amines, there is no any reaction. Here there is no any reaction because it is a bulky, both are bulky, and there is no any hydrogens to stabilize the nitrogen also. There is no any hydrogen to stabilize the, right. Next one we are going to see electrophilic substitution reaction of the aniline. The next very important concept that we are going to see, electrophilic aromatic substitution reaction of the aniline. Now aniline being the strong orthopara directing group, this is the NH2, electrophilic aromatic substitution reaction. Now aniline being the strong orthopara directing group, if suppose Br2 in the presence of carbon disulfide and the Br2 in the presence of H2O, if they have given, what are the products you will get? Now carbon disulfide is a one nonpolar solvent. Now here the NH2, and here we'll get the Br, and the another one, here the one para-bromoaniline and metabromoaniline. But we expected here the products we will get it as a para-bromoaniline and as well as a metabromoaniline we have expected. But actually the products we will not get this one. The products we will not get the para-bromoaniline and the metabromoaniline. Why? Because here the aniline being the strong ortho and the para directing group, it will in the both the cases it will generate the tri-substituted bromine on the aniline. In all the ortho position, para position, and again the ortho position. Now here what we will get the bromine, and this is a white color PPT. Here to not to get this tri-substituted product for this aniline, whatever may be the reaction you are doing, we are getting the what? We are getting the tri-substituted product. To not to get the tri-substituted product, what we have to do? Can anyone see me? Here, if you take the bromine in the non-polar solvent also, you are getting the tri-substituted product. If you take the H2O in the polar solvent also, you are getting the tri-substituted product. So first of all, now to not to get the tri-substituted product, what we have to do? We have to protect the H2O. We have to protect the H2O by doing the acylation. So my dear friends, you have to be very careful. Now this aniline in the presence of NH2, if they have given, sometimes they will give you the Br2H2O. If suppose the Br2H2O if they have given, we know we will get the tri-substituted product in this manner. Here the Br, here the Br, and here the Br we will get tri-substituted product will get. Sometimes instead of giving the tri-substituted product, they will give you this reagent BrO3 minus slash Br minus slash H plus they will give. Means here this type of the reagent they will give you also. Now the product we will get in this only. Now this reagent which will be in this manner. BrO3 minus plus 5 moles of Br minus plus 6 moles of H plus. That leads to give the 3 moles of Br2 plus 3 moles of H2. Clear? 3 moles of H2O. 3 moles of Br2 and 3 moles of H2O. The same reagent, it will be in this manner. So you have to be very careful whenever this type of the reagent they have given also. You have to get the product tri-substituted product only. So to get the only the mono-substituted product, what we have to do? We have to protect the aniline. To protect the aniline, first one, what we have to do? We have to take the acylation reaction. When we did the acylation reaction, now this nitrogen lone pair of electron will be readily attracted and it will be given to the which one? Oxygen, and as a acetic acid it will be eliminated. Now what is the product name we'll get? Here the product will get. What is the product we'll get? Here the product will get it as a acetanilide will get. The product will get it as a acetanilide. Now this is the product we'll get acetanilide. Now acetanilide is a moderate ortho-para-directing group. After generating the moderate ortho-para-directing group, now we have to take the Br2. Then after that we'll get the one mono-substituted product at ortho position, as well as one para position, one mono-substituted product, one ortho substituted product will get. Then after that, after getting this one, then if you do the hydrolysis, here the more electronegative will attract the hydrogen and the less electronegative will attract the OH, and again as a acetic acid it will be eliminated. Again the aniline will be restored. And mono-substituted products will get. Right? Directly if you do the reaction, we are getting the tri-substituted. To get only the mono-substituted product, what we have to do? First we have to protect the aniline by doing the acylation. Then after the followed by the electrophilic substitution. Then followed by the hydrolysis. Again the aniline will be restored. Right? Now this is about the halogenation reaction on the aniline. Now the second reaction we are having, that is nitration. Now this nitration is a very, very important. Now my dear friends, the direct question in your JEE mains, they are asking from this nitration. Now what is the nitration? What is the reagent we are going to use in this nitration? What is the reagent that we are going to use in this nitration? What is the reagent that we are going to use in the nitration? The reagent that we are going to use in the nitration, that is a concentrated H2SO4 and a concentrated HNO3 at 25 degrees Celsius. Now here we may think that the concentrated HNO3 and the concentrated H2SO4, when they have given, now here the electrophile we have generated, it is a nitronium ion, that is a NO2 plus, and we expected that the products are only two, that is ortho nitro aniline and the para nitro aniline. Okay, these are the two products we will get, we have expected, but actually the products we will get here, it is a three products we will get. One is a ortho nitro aniline. Now the second one is a meta nitro aniline. Now the third one is next one is a para nitro aniline. Now here the products we will get, ortho nitro aniline is a 51% major, then meta nitro aniline is a 47%. Sorry. This one, it will give you the 2%. Now this one, para nitro aniline is a 51%. They have given. Now, my dear friends, may I know why this as giving in this manner? Sorry, here only 51%, 51% will be given by the ortho and 2 will be given by the para, right? Now, may I know why the para meta product we are getting, even though this is a Due to the presence of anilinium ion. Due to the presence of this anilinium ion, it will become the strong ortho or strong meta directing group. Here, this nitrogen lone pair of electron, now due to the presence of concentrated HNO3 and concentrated H2SO4, these two are the acids. Very fastly it will generate the proton in the solution. This nitrogen lone pair of electron will be readily abstracted this acidic proton. When it has readily abstracted the acidic proton, it will become the anilinium ion. Now this one is a one anilinium ion. Now this anilinium ion is a strong meta directing group. This is a strong meta directing group. Now due to the strong meta directing group, now the NO2 will be readily attracted at the meta position. Clear in this manner. Now when we did the nitration in the reaction, we are getting the three products. My dear friend, may I know why the 51% of the ortho-nitroaniline is major? Why? May I know why the ortho-nitroaniline is major in the ortho position? Why the nitro group at the ortho position is stable in the nitrogen or in the aniline? Why it is stable? May I know? Can anyone say me why the ortho position aniline is more ortho position, the nitro group is yes, my dear friend, it is very yes, due to the presence of hydrogen bonding. Good, Pranit, good. Now due to the presence of hydrogen bonding, it is more stable, right? Due to the presence of hydrogen bonding, you have to be very careful with this one. There the hydrogen bonding will be there. Due to the presence of the hydrogen bonding, it is more stable. Now to get only the mono substituted, like ortho substituted and the para substituted nitro groups, what we have to do? Again, we have to do the same reaction. Acylation. Same to get the same reaction. What we have to do? First we have to do the acylation, then followed by the nitration. If you do, you will get the mono substituted products. Next one. Yes. Good. Next, again to get the only substituted only the which one? Mono substituted products for the aniline. First, what we have to do? Here, first we have to take the one acid chloride in the pyridine. Now, acid chloride in the pyridine, if you take, it will become the what? It will become the acetanilide. After becoming the acetanilide, then you have to take the concentrated HNO3 and concentrated H2SO4. After taking the concentrated H2SO4, now again you will get the one ortho substituted, one para substituted, one ortho substituted and one para substituted. Then after getting the ortho substituted and the para substituted, ortho substituted or para substituted after getting, now you will get the H2O and we will get the NH2 and ortho meta para. At the para position we are having the NO. Clear? Now this is which one? This is we are getting at the para substituted, because the para substituted is major. But if you want the ortho substituted nitro, then we have to follow the two steps. What we have to follow those two steps? If we want ortho substituted product only, if we want ortho product only, then what we have to do? First, this aniline we have to react with the acid chloride. we have to react with the acid chloride. Now here in the acid chloride, we know, right, in the acid chloride, aniline, hydrogen and the Cl will be eliminated. Here the C will go, here the CH3. Now one hydrogen from here, one hydrogen and one Cl, it will be eliminated, and it will form the one acid, what, acetanilide. After forming the acetanilide, here we have to take the one concentrated H2SO4. First we have to take the concentrated H2SO4. From the concentrated H2SO4, SO3H is a electrophile, it will be generated, that it will go and attack at the which position? Para position. Clear? Now after generating the para position, now we have to take the concentrated HNO3 and concentrated H2SO4. Now if you take the concentrated HNO3 and the concentrated H2SO4, now this is a nitronium ion, is a electrophile. Now here it is not having a chance to go to the para position. By para position already sulfonic acid it is attacked. So it is having only the chance to attack at the which position? Which position? It will be attack at the only ortho position. Then it will go and attack at the ortho position. Then here we are having the acetanilide. Then here we are having the SO3H. Then after this SO3H, upon heating and the H2O if you do, you will get the aniline here. And the SO3H is a one dehydrated, what it is a one volatile, more volatile, it will be eliminated from the solution. Clear? Again we will get the ortho nitro product. So this is the one key step you have to remember. To get only the ortho nitro aniline, first we have to do the sulfonation reaction. Then after the followed by nitration reaction. Okay? I hope it is clear for you. First you have to do the which reaction? First you have to do the sulfonation, then followed by the nitration. Now next one, the next one we are having the sulfonation reaction. Now in this sulfonation reaction, we are having the aniline in the presence of H2SO4. First it will be converted into the nitrogen lone pair of electron will be readily abstract the which one? The electrophile. Right? Here it will get the positive charge. Right? Now to stabilize this positive charge, this hydrogen, here the 2 and we are having the hydrogen. Now this bond pair of electron will be delocalized and this HSO4 minus it will go and attack at the para position at a high temperature 453 Kelvin to 473 Kelvin. Then it will be formed in this manner. It will be formed in the one NH2 and one SO3H. Now this nitrogen, it is having the lone pair of electron will readily abstract this acidic proton. Now this acidic proton will be present in the form of the deuter ion. Now it will be present in the form of the deuter ion like this. Now this one we call it as a deuter ion. It will be present in the form of deuter ion. Right? Clear? Now next very important reaction that we are going to study, that is a Friedel-Crafts alkylation. The next reaction that we are going to study, that is a Friedel-Crafts alkylation. My dear friends, can anyone say me? Now the NH2 when it has reacted with the Rx and the AlCl3, if it is reacted, what is the product we will get? My dear friends, can anyone say me what is the product we'll get? Anyone who is in the live? Anyone is in, if it is in the live, can anyone say me the answer? My dear Praneeth, uh, I hope you have studied well and still you are giving the wrong answers. My dear friends, once you cross check what is the product you will get, you are saying this is a tauridine, you are saying. Tauridine, you are saying the answer, but actually here there is no reaction is possible. No, here the reaction is not at all possible. Why? Here the alkali halide in the presence of AlCl3. No reaction here. Aniline upon Friedel-Crafts alkylation, no reaction. Why? Here to generate the alkene as a electrophile. Now this Lewis acid should be accept the lone pair of electrons on the chlorine. Then after that here the electrophile should be generated. But here this Lewis acid which it is present here, instead of accepting the lone pair of electron from this alkali halide, very fastly it will be accept the electrons from the nitrogen. Nitrogen lone pair of electron, very fastly it will be given to the AlCl3. When it is given very fastly to the AlCl3, it will become anilinium ion, right? It will become the one nitrogen, it will get the which charge? Positive charge. When the nitrogen, when it has become the positive charge, it will become the what? Strong strong meta-directing group it will become. Strong, which directing group? It will become the strong meta-directing group. If the strong meta-directing group, if it is became, how come the electrophile will be generated? There is no any chance of generating the electrophile here, because already this Lewis acid is the role. This Lewis acid will play the key role to generate the electrophile. Already this nitrogen lone pair of electron is accepted by this Lewis acid. Then how come it will be react with this alkali halide? There is no any chance of generating the electrophile only. So there is no reaction. My dear friend, you have to be very careful with this type of the reactions. Aniline upon Friedel-Crafts alkylation, there is no reaction. I hope it is clear. I hope it is clear for you. It is clear. Still you are having any confusion? Still you are having any confusion, or it is clear? Right. Okay, done. Now, next one. We are going to see the diazonium salt. The next reaction that we are going to see is the diazonium salt. The diazonium salt reaction that we are going to see. Now, in this diazonium salt, the first one we are having the methods of preparation of the diazonium. Already I was explained the mechanism very carefully. No need of remembering the mechanism. Just how to prepare the diazonium. NaNO2 in the presence of HCl, 0 to 5 degrees Celsius. Very fastly it will become the diazonium chloride. In this manner, the diazonium chloride it will become, and the NaCl and the 2 moles of H2. After preparing the diazonium chloride, now we have to do the reaction with this diazonium chloride. When we are doing this reaction with the diazonium chloride, now here the two types of the reaction we are having. One is a Sandmeyer's reaction. Now what are the Sandmeyer reaction? This is a benzene diazonium chloride. Now what is the reagent that we are going to use in the Sandmeyer reaction? Can anyone? Now here it is a CuCl in the presence of HCl. Now here it is a CuBr in the presence of HBr. Now here it is a CuCN in the presence of in the presence of KCN heating. My dear friends, here you will get the chlorobenzene. Here you will get the which one? Chlorobenzene. Here you will get the bromobenzene. Right? Here you will get the benzonitrile. You will get the benzonitriles. Right? And the N2 gas will be released. My dear friend, now can anyone say me in these reagents what is the change in oxidation number? What is the change in oxidation number of the Cu? I mean, Cu is oscillating its oxidation number between Cu oxidation number oscillating between Cu oxidation number is oscillating between. Can anyone? Now in this Sandmeyer reaction, between +1 comma and +2. Cu oxidation state is oscillating between +1 and the +2 in the Sandmeyer reaction. Right? Next one, the another type of the reaction we are having, that is a Getterman's reaction. The next reaction that is we are having Getterman's reaction. Now in this Getterman's reaction, again we are having the benzene diazonium chloride in the presence of CuHCl, right? And the next one we are having the CuHBr, right? Here we will get the chlorobenzene and here it will get the bromobenzene. Clear? Now in this reaction, Cu oxidation state oscillating between Cu oxidation state oscillating between here it is oscillating between +1 to 0, right? Now +1 to 0. Next one, we have seen the Sandmeyer reaction and we are seeing the Getterman reaction. In the Sandmeyer reaction also we are preparing the chlorobenzene. In the Getterman reaction also we are preparing the which one? Chlorobenzene. Now the more healed we will get in by the which reaction? More healed is absorbed by which reaction? More healed is absorbed by which reaction? Sandmeyer reaction or Getterman reaction? More healed is absorbed by the which reaction? Sandmeyer reaction or Getterman reaction? More healed we can see. Good. The more healed is absorbed in the Sandmeyer reaction. Sandmeyer's reaction than the Getterman reaction. Clear? Due to the free radical mechanism. In the Getterman reaction, nucleophile was introduced due to the free radical mechanism. Clear? That's the reason the more healed we will get it in the Sandmeyer reaction, because in the Getterman reaction nucleophile was introduced on benzene through free radical mechanism. Through the free radical mechanism it was introduced. The more the side chain products will be there. Clear? That's the reason the Sandmeyer reaction will give you the more yield than the Getterman reaction. You have to be very careful with this one also. Okay? Now, next one we are going to see the preparation of iodobenzene. Next one we are going to see preparation of the iodobenzene. Now the preparations of iodobenzene. Preparation of iodobenzene. Now what is the reagent we are going to take in this preparation of the iodobenzene? Now benzene diazonium chloride plus Ka upon heating. Ka upon heating. Here you will get the one iodobenzene plus KCl plus N2. KCl plus N2. Clear? The next one, very important one, named reaction. That named reaction, the repeatedly they are asking with the name also they may ask. That reaction we call it as a Balz-Schemann reaction. That is a Balz-Schemann reaction. In this Balz-Schemann reaction, we are having the benzene diazonium chloride when it has reacted with the clear. Now fluoroboric acid when it has reacted with the which one? Fluoroboric acid. Now in this fluoroboric acid, when it has reacted, it will form the when it has reacted, it has formed the fluoroborate. Now this one is a fluoroborate. Now this fluoroborate upon heating, it will be converted into the fluorobenzene. It will be converted into the fluorobenzene and the byproducts are the BF3 and one is the N2 gas. This is very, very important. You have to be very careful with this one. Next one. Now the substitution of hydride ion. This is also one very, very important. Now this one is a which one? Benzene diazonium chloride in the presence of H3PO2 plus H2O. From this H3PO2 we will get the which one? Hydride. We will get the one hydride. Now here the benzene diazonium chloride. Now in the presence of this H3PO2 and the H2O, benzene diazonium chloride, it will be eliminated and we will get the benzene. You have to be very careful with this one. Engine and you will get the N2 and you will get the H3PO3 and you will get the byproduct HCl. Here the byproducts also they will ask in this substitution of hydride ion in this H3PO2 and H2PO2, what is the basicity of this H3PO3 they will ask. In the preparations of this one, what is the basicity of this acid in the product? Now can anyone say me what is the basicity of the acid in the product? What is the basicity of acid in the product? The basicity of the acid in the product is H3PO2, right? There. Now this is the basicity of the acid is 2. Right. Good. Basicity of the acid is 2. Next. The next one we are having, that is substitution. Preparation of nitrobenzene. Now the preparation of the nitrobenzene. Preparation of nitrobenzene. Now how to prepare the nitrobenzene? Now we know this is a benzene diazonium chloride. Same, again we have to react with the HBF4. It will become the fluoroborate. It will become the which one? Fluoroborate. After it will become the fluoroborate, then here we have to take the NaNO2 and Cu and heating if you do. Now it will be eliminated and you will get the nitrobenzene. These are the reagents you have to remember. They will ask you the reagents itself. Nothing they will ask. And the next type of the reaction we are having the coupling reaction. Coupling reaction, my dear friend, there is no need of remembering the mechanism and the coupling reaction. Just to you remember the only one thing. What? Now benzene diazonium chloride, if they have given in the presence of phenol, if they have given in the presence of basic medium, now the pH we have to take from the range of 9 to 10, from the 9 to 10, then the products we will get it as a, what is the product we will get? The products we will get it as a, now this is a product we'll get, this is a p-hydroxy azobenzene, p-hydroxy azobenzene will get. May I know what is this color of this one? What is this color of this one? Can anyone say me what is the color of this one? Benzene diazonium chloride in the presence of the phenol. Benzene diazonium chloride in the presence of phenol. pH at the 9 to 10. It will give you the, no, it will give you the orange color dye. This is orange color. This is orange color dye. My dear friend, this is orange. If it is aniline, it is yellow color. If it is aniline, it is yellow color. Yes, pH and the NH2 if they are given. Now here the pH should be 4 to 5. pH should be 4 to 5. Now here the yellow color dye. If it is a phenol, that is orange color dye. If it is a aniline, you will get the yellow color dye. Yellow color dye, right? Done. Now, my dear friends, the only leftover the part we are having loss and rearrangement, Curtis, and that rearrangements that we will see tomorrow. Now we'll do some questions. Now some question based on these questions. Now we'll see the whatever the concept we have studied based on this concept. Now we'll do some questions. Okay. C2. System. Vandana, may I know what is the meaning of system? You can ask. You can ask. Pranit, you can ask. What is your doubt? You can ask. No problem. You can ask. You can ask, my dear. You can ask. That also it will be formed. Why you are not getting? That it is easy, right? You know why you are not getting that product? Why you are not getting? Once you try, you will get. Once you draw the structure and try. Once you draw the structure and try it from your end. What the hydrogen eliminating? You are saying if they are given the beta naphthol. Once you draw the structure, I will say. Once you take the diazonium chloride and the beta naphthol, from the starting onwards, if you do the reaction, you will get the answer. I mean, what is the doubt you are having? I am not getting. You are saying the beta naphthol and you are saying the aniline with the alpha and beta naphthol. I mean, what you want to identify? Alpha and beta positions are. Functional group adjacent carbon is a alpha. and the second carbon is a beta, right? Pranit, whatever the doubt you are asking, I was not understanding. I mean, this is a beta naphthol. This is a beta naphthol. Then, what is the doubt you are having in this? What is the doubt you are having? This is a, if they have given, sorry, this is aniline, right? Beta naphthol. This is a beta naphthol, I think so. Here now, aniline with alpha beta naphthol, sorry, Ola, okay. This is a beta naphthol. Clear? This is a beta naphthol. Coupling with aniline. Now this one is coupling with the aniline. pH, and this is the NH2. Right? Now eliminate the hydrogen at this alpha position. Eliminate the hydrogen at this alpha position. Now, if suppose the beta naphthol they have given, you can see this is a aniline. And if suppose the beta naphthol if they have given, if suppose the beta naphthol if they have given, if the beta naphthol if they have given, now the hydrogen will be eliminated from here. Now the product you will get, in this manner. Right? Here it is a product you will get. This is a 1-phenyl azo 2-naphthol. This is orange color dye. 1-phenyl azo 2-naphthol. Orange color dye you will get. Now if you take this reaction with the 1-naphthol, if you take the reaction with the 1-naphthol, now the coupling will be happen at this position. If the 1-naphthol they have given, coupling will be happen at this position. If the beta naphthol if they have given, the coupling will be happen at this position. Clear? Acha. 1-naphthol. This is the beta naphthol. Beta naphthol, the coupling will be happen here, and this is the orange color dye. Now for the 1-naphthol if they have given, or alpha naphthol if they have given, if the alpha naphthol if they have given, the coupling will be happen at this reaction. Okay? Now let's suppose if both the positions, if they have given both the position alcohol and the phenol they have given, here one alcohol and here one aniline if they have given, clear? Now may I know where the coupling will be takes place? If they have given in this manner, at which position the coupling will be takes place? Now this is with the beta naphthol, coupling is happened at this position. Now 1-naphthol, for the 1-naphthol the coupling will be happened at this position. Now at which position the coupling will be happened? Then you have to be very careful. Then you have to be very careful with the Then you have to be very careful with the medium. Medium you have to cross check. Here you have to cross check the medium. Medium you have to cross check and you have to do the reaction. If the pH N2Cl minus if they have given, you have to check the medium. If it is a basic medium alkaline solution medium or alkaline medium. Now the coupling will be happen at the ortho to the OH. Ortho to the OH coupling will be happen, right? When the medium is basic. If the medium is acidic, then the coupling will be happen ortho to the aniline. Is it clear? If the acidic medium, ortho to the aniline. Basic medium, ortho to the which one? Alcohol. Yes. Okay, done. Now next one, very important, my dear friend, you have to remember that if suppose ortho to the if the OH is the given, next one, and one carboxylic acid if they have given. Now again, if the coupling reaction if they have given N2 plus and Cl minus, and the pH they have taken 9 to 10. Okay. Next, same. Here the OH and the SO3H they have given. Okay. Sulfonic acid, the same benzene diazonium chloride in the presence of pH 9 to 10. Now may I know what are the products you will get and where the coupling will be happen? May I know where the coupling will be happen? May I know where the coupling will be happen? If you know, say me. If not, I will explain. Where the coupling will be happen? May I know? If you know, say me. If not, I will explain. No, here this carboxylic acid will be eliminated. Now when the which one? Para-hydroxybenzoic acid if they have given, para-hydroxybenzoic acid if it is given, this carboxylic acid it will be eliminated and the coupling will be happened. Carboxylic acid as a H2O gas, CO2 gas, it will be eliminated and here the coupling will be happened. Carboxylic acid will be eliminated and it is an example of ipso substitution. It is an example of ipso substitution. This is a ipso substitution. You have to be very careful in this. Whenever the para-hydroxybenzoic acid if they are given, the coupling will be happened as a carboxylic acid will be eliminated and the coupling will be happened. Now, right? If suppose a sulfonic acid also they have given, same. Sulfonic acid also will be eliminated. Now, here the coupling will be happened. Right? Not only with the OH, with the NH2 also it will be happened. Same. Right? Is it clear? Okay, fine. Right now, okay, my dear friends, I will stop the class now here. I will stop the lecture now here. Tomorrow we'll see the complete question sessions. Complete question session, and day after tomorrow, better tomorrow we'll see the complete question session. Only the one topic is left. That topic we will I will complete it by the within 10 to 20 minutes. Then after that we'll do the complete questions. Okay. Right. My dear friend, I will explain what is the meaning of Lessons test. Lessons test is nothing but making the organic compound, unknown organic compound into the ionic compound is known as the Lessons test. Clear? You have to take the one unknown organic compound in the which one? One in the small test tube. In that small test tube, you have to add the which one? Sodium metal. Then you have to heat that one into the red hot tube. And then after you have to heating that tube will become the red hot. Then you have to drop it into the mortar pestle. After dropping into the mortar pestle, you have to crush that one. That you have to crush. When you have crushed that one, and you have to take the filter and you have to filter it out. Now whatever the extract you have got, that extract we call it as a Lessons test. That Lessons test is nothing but making the organic compound into the, most of the organic compounds are covalent in nature, we know. So making the organic compound into the ionic compound is nothing but Lessons test. That I will explain. Don't worry. Okay. Now we'll see you tomorrow. Bye. Okay, my dear friends, we'll see you tomorrow. Bye.